Welcome to the second part of the Introduction to Research Methodology, in which we are going to look at what is research. So, what is research? It's any systematic investigation that we do with an open mind to establish novel facts, to solve new or existing problems, to prove new ideas, or to develop new theories. And our objective here is, again, to develop new knowledge. So basically, after your study, you should ask yourself, if I've completed this study, what do we now know that we did not know before? And the reason we are building on this new knowledge is that all of science builds on knowledge that went before. As Newton said, he could only see a little further because he was standing on the shoulders of giants like Copernicus and Galileo and Aristotle and a number of others before him. But what is research not? It is not simple information gathering. It is not moving facts from one place to another. It is definitely not surfing the web. And definitely not talking to your friends. It's also not just reading books or magazines or newspapers, but all of these can be used to do research. So how is research different from collecting information? If we go back to our original definition of research, where we talk about systematic investigation, so it follows a particular plan, it has a method. It has a particular goal. You're not just collecting things because you're interested in the information. It is also done with an open mind. In other words, it's objective, it's unbiased, and it's skeptical. Now, why do I talk about why skeptical? A skeptic is somebody who questions accepted truths, and that is what a scientist is at heart. Scientists don't deal in the business of truth, they deal in the business of limited and approximate descriptions of reality. The good scientist knows that his truth is only valid until somebody else has disproven it through new knowledge that came about. For example, for many years, most people in Europe believed very firmly that the sun revolves around the earth, while the rest of the world actually knows that it was the other way around, with the earth revolving around the sun. There are still people in America who believes that the earth is flat. Again, something that people thought because of their limited perceptions of reality. But the moment they started thinking more about it, they could actually discover very early on that the earth is round. So the science fiction writer Arthur C. Clarke always talked about Clarke's laws. These things that he uses as basis for science fiction, but that is something that tells us that in basic science, nothing is impossible. We can never exclude anything because we think it is possible. And the first of these laws is that if somebody who's a distinguished or an elderly scientist tells you that something is possible, he's almost certainly right. When he tells you that something is impossible, he is very probably wrong. And that the only way that we can discover the limits of the possible is if we sort of venture a little bit past them into the realm of the possible. So a scientist is also always pushing past the possible, always testing the limitations of accepted truths. Because any sufficiently advanced technology is indistinguishable from magic. Now, if you take some of our modern technologies like cell phones, for example, or even electrical lights, to any place in the world 300 years ago, people would be burning you on the stake. So what is the characteristics then of formal research? It starts with a question or a problem. We have a clear goal, what it is that we want to achieve, the purpose of our study. And then we have a methodology, a specific plan or a procedure, how we're going to go about answering this question. And this plan or our methodology is guided by our specific research problem or the relevant hypothesis that we're trying to test. And it accepts certain critical assumptions. So there are things that it says, we accept these as true. We're not going to go into the debates around this particular truth. And it requires the collection and the interpretation of data to resolve the problem that initiated this research. And again, as I said, explained in the first slides, if we look at the scientific methodology, research is iterative. We always go back and say there's new things, new questions that came up that also now needs to be answered. So how do we describe research? Firstly, it's in terms of your purpose. So when you start telling, this is talking about your particular research and you write your research methodology. You have to say, well, what is the purpose? What am I doing this? And then, is this an exploratory study? Am I trying to describe something? Am I analyzing a particular thing? Or is it a predictive study? Then you have to talk about the process. So how will I collect and analyze my data? Am I looking at quantitative data or am I looking at qualitative data? And what is the logic I'm going to follow? Am I going to move from observations to theory, so from the specific observation, to a more general theory? In other words, my logic is inductive. Or do I move from general to specific? So I move from a theory to an observation. So in other words, to test my theory, whether my observations support the theory. That is deductive knowledge. And most of hypotheses are deductive knowledge. And lastly, we look at what is the outcome of our research. Are we contributing to general knowledge, a general theoretical basis? Are we solving a particular problem? Or are we developing a solution to something? The Frascati model of research identified three major categories of research according to the outcome. And these three spans from theory to reality. So on the one side, you have basic fundamental research, you have applied research, and then you have experimental development. Now, basic fundamental research is those usual things like what we see the real scientists do, such as quantum physics. For example, the Large Hadron Collider, people are shooting things around and seeing what is happening, but it doesn't have a practical application yet. Applied research takes the knowledge that was derived from the basic or fundamental research and asks questions like, how is this now applied in the real world? For example, what is the effect of quantum properties on electromagnetic waves? And in an experimental development, we will take that knowledge to develop something practical, such as a cell phone. And you do experiments in all of these categories. So if we look at what is basic research, experimental or theoretical, and the idea here is that it is about acquiring new knowledge about what underlies everything that we see, our phenomena that we observe, and anything that we see around us. But we don't particularly think about how this knowledge will be used. It's mainly motivated by curiosity. You get two types of basic research. The one is this pure basic research, the blue sky research, like the Large Hadron Collider. And in there it is just scientists asking fundamental questions, but there's no particular purpose behind it. So there's no sense of, we want to answer these questions, we want to get this knowledge so that we can get some kind of long-term benefit out of the knowledge or solve a practical problem with this. And then we have oriented or strategic basic research. It's still based in theory, developing a broader base of knowledge, the foundational knowledge. But here, there is an idea that we want to develop this as a background to solve identified problems. Applied research is where we have still, it's an original investigation and it's still about new knowledge, but it has a particular practical aim or objective, or a very specific objective. And it's designed to answer specific questions or solve practical problems. And from here, we can then move to experimental development, where we draw on this existing knowledge that we've gained now from our research or from practical experience. And the novelty here is new materials, new products or services, or it is about designing new processes or systems, or improving those things that have already been produced or installed. For example, in basic research, we have the theoretical investigation of the factors determining regional variations in economic growth. So you see, here we are dealing with theory. Now, moving that into applied research, we use this theory to investigate how we should develop government policy. And lastly, in terms of experimental development, is where we use the knowledge that we got from our basic research to develop operational models of economic growth stimulation that is based upon those laws that we've revealed through our research and that is aimed at modifying regional disparities, which we identified when we developed, for example, government policy. So the next section is our second theme, and this is about research planning and design. Thank you.